Everyone, in this we are going to see vector calculus in unit 1 as a differentiation of vector. So today we are going to see the topic of gradient. So that is, gradient is nothing but del pi. First of all, we have to see the value for del. Del is nothing but I vector tau by tau x plus j vector tau by tau y plus k vector tau by tau z. So for the gradient del pi, just multiply pi with x, y, z, that is I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. Some of the notes are given here. First, see, del is a vector differential operator. So the value of del can also be expressed as summation I tau x, which can be expanded with y and z. In note 3, del pi is composed of three components, which is nothing but tau pi by tau x, tau pi by tau y, tau pi by tau z. In the fourth point, if pi is a constant, del pi value is 0. Del pi should not be written as pi del or del dot pi or del cross pi. It should be written only as del pi. In the sixth point, pi of f plus or minus g can be written as del f plus or minus del g. Similarly for the constant c1 and c2. In the seventh example, del of pi 1 pi 2, which is uv method, u v dash plus v u dash, that is pi 1 del pi 2 plus pi 2 del pi 1. Similarly, pi of pi 1 pi 2, that is differentiation of u by v method. So v u dash minus u v dash divided by v square. So pi 2 into del pi 1 minus pi 1 into del pi 2 divided by pi 2 square. The last ninth note, v is equal to f of u. Then if differentiate, so del u is equal to f dash of u into del u. Now we are going to see some of the problems in gradient, and also some more topics are given below. So first see, in the third example, if pi is equal to x, y, z, then find gradient, that is del pi. So we know that the value of pi is x, y, z, and also we know the formula for del pi, that is I vector tau pi by tau x plus j vector tau pi by tau z plus k vector tau pi by tau z. So now compare the value this with pi, that is multiply pi with respect to x, differentiate pi with respect to x. So the value will become yz. Second term, differentiate pi with respect to y, we get xz. Third term, differentiate pi with respect to z, we get xy. So that is yz I vector plus xz j vector plus xy k vector. See, in the fourth example, similarly we have to find del pi, that is we have to find the value of gradient. First of all, write the given term as it is, that is pi is equal to log of x square plus y square plus z square. We know the formula for del pi. Write it. First of all, differentiate pi with respect to x. We know that log r, that is differentiation of log r is nothing but 1 by r. So here differentiation of pi, that is 1 by x square plus y square plus z square. So with respect to x, which means it will become 2x. Similarly for y and z, in all the three terms we have 2 divided by x square plus y square plus z square as common term. Take it outside. So the remaining terms are put it in the bracket, which is x I vector plus y j vector plus z k vector. We know this value is referred as r vector, and x square plus y square plus z square can be written as r square. So the value for del pi is 2r vector divided by r square. Similar examples are given below. Okay, in the second one we are going to see directional derivative. So directional derivative formula is del pi into a vector divided by modulus a vector. First of all, we have to find the value of del pi. Then a vector is nothing but given direction, and for that we have to take modulus. See, in the first problem, find the directional derivative of pi is equal to x square yz plus 4xz square at 1 comma 2 comma minus 1 in the direction of 2i vector minus j vector minus 2k vector. This direction can be taken as a vector, and the value of 1 minus 2 minus 1 is nothing but the value of x, y, z. Now write the given pi value x square y z plus 4x z square. Now del pi, so differentiate pi with respect to x, with respect to y, with respect to z. We get the value del pi as 2xyz plus 4z square. Now second term differentiate with respect to y, we get x square z j vector. Third term differentiate pi with respect to z, we get x square y plus 8x z k vector. Now we have the point, so substitute for x, y, z, we get 8i vector minus j vector minus 10k vector. So a vector is given direction, write as it is. For this we have to take modulus. So modulus is nothing but take square root and square the coefficient of ijk. So square root of 2 square plus minus 1 the whole square plus minus 2 the whole square, root 4 plus 1 plus 4 value is root 9. 9 can be written as 3 square. Square and square root cancel out each other, we get the value 3. Now we have to write the directional derivative formula and substitute the value. So we get 8i vector minus j vector minus 10k vector into 2i vector minus j vector minus 2k vector divided by 3. Now compare these two terms in the bracket as I, j, k. We get 8 2s are 16 plus minus 1 into minus 1 is plus 1 plus minus 10 into minus 2 is plus 20. Add all the three terms, we get 37 and the denominator value is 3. Here the directional value is 37 divided by 3. Similar example is given below. Find the directional derivative of pi value given and x, y, z value given, and also a vector value is given. Write down the formula for del pi. Differentiate pi with respect to x, y, z, we get the term. For that we have to substitute the value for x, y, z as 1, 2, 3. We get 54 I vector plus 6 j vector plus 28 k vector. Now write the a vector and take modulus for that. We get root 2 square plus 1 square plus minus 1 square. We get root 6. Now write the directional derivative formula and substitute all the value. Compare I, j, k value. So we get 1 by root 6 into 86. Similarly, we can prove the next sum. This is how we can find the value for directional derivative using the formula del pi into a vector divided by modulus a vector. Okay, our third topic is unit tangent vector. So unit tangent vector is nothing but dr vector divided by dt divided by modulus dr vector by dt. We already know that r vector value is xi vector, yj vector and zk vector. Differentiate it with respect to t. First of all, we see the example. First example, find the unit tangent vector to the following surfaces at the specified point. So x value given, y value given, z value given, and also at the point t is equal to given. We have to find unit tangent vector, that is we need to find dr by dt divided by modulus dr by dt. So r vector we know the value, write it is. Substitute for x, y, z, that is t square plus 1 for x, 4t minus 3 for y, 2t square minus 60 for z. Now differentiate r vector with respect to t. So in the first term t square will become 2t I vector. Second term 4t will become 4j vector. In the third term 2t square will become 4t minus 60 will become minus 6 into k vector. For this we have to substitute the point t as 2. So our answer will become 4i vector plus 4j vector plus 2k vector. We have to take modulus for this. So it will become root 4 square plus 4 square plus 2 square, that is root 16 plus 16 plus 4, which is root 36. 36 can be written as 6 square. Square and square root cancel out each other. Our value is 6. Now unit tangent vector, write down the formula. substitute for the formula. In this numerator we can take 2 as common outside. So 2 and 6 cancel out each other. So our denominator will become 3 and the numerator will become 2i vector plus 4j vector plus 2k vector. This is how we can solve for the unit tangent vector with the formula dr vector by dt divided by modulus dr vector divided by dt. Our fourth topic is normal derivative, that is modulus for the gradient, that is modulus del pi. See the first question, find the normal derivative of pi value given and also the point x, y, z value is given as minus 1, 1, 1. We need to find normal derivative. First of all, write the pi value as given in the question. Next we have to find del pi first. Already we know the formula, right? First of all, write the formula. Then compare with pi with respect to x, y, z. We get the value y plus z I vector plus x plus z j vector plus x plus y k vector. For this substitute x, y, z as minus 1 plus 1 plus 1. We get 2i vector plus 0 j vector plus 0 k vector. So 0 is left here, just write 0 k vector. So take modulus for this because our normal derivative formula is modulus del z, which is root 2 square. Square and square root cancel out each other. So our answer is 2. See the second example. For the normal derivative, here the words given as greatest rate of increase, which is similar as normal derivative. What is the greatest rate of increase of pi is equal to x, y, z square at 1, 0, 3. So in solution, given pi is equal to x, y, z square. So write the formula for del pi. So differentiate pi with respect to x, we get y z square. Differentiate pi with respect to y, we get x z square. Differentiate pi with respect to z, we get 2xy z. Now substitute for x, y, z value as 103. We get 0i vector plus 9j vector plus 0k vector. Now greatest rate of increase, which is nothing but normal derivative modulus del pi, which is root 9 square, square and square root cancel out each other. So our value is 9. Our fifth topic is unit normal vector. So unit normal vector is nothing but n cap is equal to del pi divided by modulus del pi. First we have to find the gradient and also we have to find the modulus gradient. In the first question, find the unit normal to the surface x square y plus 2x z square is equal to 8 at the point 1, 0, 2. So this is nothing but the surface is written as pi. So the pi value is x square y plus 2x z square plus 8 will become minus 8 to the next side. So write minus 8. Now del pi. So differentiate pi with respect to x. We get 2xy plus 2z square I vector. Second, differentiate pi with respect to y. So first term containing only y, so it will become x square j vector. Third, differentiate pi with respect to z. In the first term there is no z. In the second term there is z square. If we can differentiate, we get 4xz k vector. Now we have to substitute the value of x, y, z as 1, 0, 2. It will become 8i vector plus j vector plus 8k vector. Now we have to substitute this del pi value and modulus del pi value in the formula. So unit normal vector is equal to del pi divided by modulus del pi. Substitute the value of del pi in numerator and the denominator will become square root 8 square plus 1 plus 8 square. So 8 square value is 64 plus 1 plus 64. Answer is square root of 129. Similar example is given in the second one. See, find the unit normal vector to the surface x square plus y square minus z is equal to 11 at 1, 1, So take this surface as pi is equal to x square plus y square minus z minus 11. So unit normal vector. So we need del pi and also modulus del pi. So first of all we will find del pi. Del pi formula is I vector tau pi by tau x plus j vector tau pi by tau y plus k vector tau pi by tau z. So first of all differentiate pi with respect to x, we get 2x I vector. Second, differentiate pi with respect to y, we get 2y j vector. Third, differentiate with respect to z, we get minus k vector. We have to substitute the value of x, y, z, that is 1 comma 1 comma 1. We get 2i vector plus 2j vector minus k vector. Finally we have to find the modulus del pi value, that is square root of 2 square plus 2 square plus 1 square, that is root 4 plus 4 plus 1, which is root 9. 9 can be written as 3 square. Square and square root cancel out each other, so our value of denominator is 3. So unit normal vector, write down the formula first. Del pi divided by modulus del pi. So del pi value is 2i vector plus 2j vector minus k vector, and modulus del pi value is 3. This is how we can find for the unit normal vector. This all the 5 terms are related to the gradient. And also the sixth topic, see the sixth one, find the angle between the surfaces. So angle which is theta, so cos theta is equal to del pi 1 into del pi 2 divided by modulus del pi 1 into modulus del pi 2. And also theta can be found as cos will become cos inverse to the next side and the remaining in the bracket. See the first question, find the angle between the surfaces. Z is equal to x square plus y square minus 3 and x square plus y square plus z square equal to 9 at 2 comma 1 minus 1 comma 2. Here two surfaces are given, so we can take it as one as pi 1 and another as pi 2, because we need to find the value for angle between the surface is del pi 1 del pi 2. Then we have to take modulus for that. This is the format to find the answer. First of all, take first surfaces as pi 1, that is x square plus y square minus z minus 3, and pi 2 as x square plus y square plus z square minus 9. Now differentiate this pi 1 with respect to x, y, z. We get 2x I vector, 2y j vector minus k vector. On the next side, differentiate pi 2 with respect to x, y, z. We get 2x I vector plus 2y j vector plus 2z k vector. Now we have only one point as 2 comma minus 1 comma 2. Substitute it for x, y, z. We get 4 I vector minus 2 j vector minus k vector for del pi 1. 4 I vector minus 2 j vector plus 4 k vector for del pi 2. Now we have to take modulus for both del pi 1 and del pi 2. We get square root of 4 square plus minus 2 the whole square plus minus 1 the whole square, which is square root of 16 plus 4 plus 1, which is square root 21. Similarly for modulus del pi 2 we get square root 36, which can be written as 6 square. Square and square root cancel out each other, so the answer is 6. Now we can write the formula for angle between the surfaces, that is cos theta is equal to del pi 1 into del pi 2 divided by modulus del pi 1 into modulus del pi 2. Substitute all the value and simplify it. We get 8 divided by 3 root 21. Finally we can also find the value of theta, that is bring this cos to the next side. So cos will become cos inverse to the next side. Theta equal to cos inverse of 8 divided by 3 root 21. Here one more example is given for angle between the surfaces. X log z equal to y square minus 1 and x square y is equal to 2 minus z at the point 1 comma 1 comma 1. Similarly pi 1 and pi 2 value is given here. We need to find del pi 1 del pi 2 and substitute the value of 1 comma 1 comma 1 to x, y, z. Then we have to take modulus for del pi 1 and also del pi 2. So our formula for angle between the surfaces is cos theta is equal to del pi 1 into del pi 2 divided by modulus del pi 1 into modulus del pi 2. Substitute all the value here. Finally we get 1 by root 30. Then again we need to find the value of theta, which is equal to cos inverse of 1 divided by root 30. So in this section we already saw the formula for the gradient, which is del pi. Then many topics, that is 6 topics we referred here. In the next session we are going to see divergence, curl, solenoidal and irrotational vector. Thank you all.